Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. In this section, we are going to discuss how to find integration using integration by bar techniques. To start with the integration by bars, we are going to redefine or restate the product rule. The product rule of the derivative given by d by dx of u v is equal to u prime or du multiplied by v plus v du. The integration by part is equal to the derivative of the first function multiplied by the second plus the derivative of the second one multiplied by the first. Now, if we integrate d by dx of this one equal to the integration of du v plus that one should be u dv. Now the integration for this one will be plus integration of u dv. And as we know that the integration and the derivatives or differentiation are opposite of each other, so this one will cancel this one. So I will have uv equal to integration of v du plus integration of u dv. Now, if we want to find this integration, so the integration of u dv is equal to, move it to the other side, it will be u v minus integration of v du. This technique now is known as to be the integration by part. So the integration by part is just integration of product of two functions. Which one? The first one is just a function u, and the second one is dv, and then we want to integrate by part to find the solution for some problem. And the idea for integration by part is just to make the given question easier to find. To explain this idea in detail, let's start with some examples. Example number one. Evaluate. Number one. Integration of x multiplied by cosine x square dx. We have discussed this in fund integration by substitution. And we say that in that technique or integration by substitution, we are finding the relation between some functions. In this one, we can see x and x squared, they have some relation, that x is just the derivative of x squared with some constant divided by 2 or multiplied by 2. X is just the derivative of x squared, and that's why we are using by substitution. This one can be integrated by substitution. Substitution, we said that let u equal to the angle, which is x squared. This will give me du equal to 2x dx, or dx is equal to du divided by 2x. So the integration will be now x multiplied by cosine of u, dx is du over 2x. By simplifying, I will cancel x with x. I will have 1/2 integration of cosine of u du, which is equal to 1/2 sine u plus constant c, which can be written as 1/2 sine x squared plus some constant c. This is integration by substitution, the one that we have discussed before. Now, if some cases the integration of x multiplied by cosine x dx. Now I have x and x there, which means there is now the first x is not the derivative of the second one. If I have this way, or this variable x to the power 1 and cosine x to the power 1, I cannot apply the integration by substitution. We cannot find it using the integration by substitution. So I'm going to use different techniques to find the integration, and that one will be integration by part. To explain this in detail. Integration by part say that it is integration of u dv equal to u v minus integration of v du. So if this is my function or my integration, u dv, it means multiplication of two functions. So I need to choose one of the function to be u and one of them will be dv. So I will let u equal to x. And dv equal to cosine x dx. I have two parts. First part is x, second part is cosine x dx. So I will let u equal to x and dv equal to cosine x dx. The question will be, why did we choose u to be x, not cosine x? I will answer this in the coming example, in the next one. Now, let u equal to x. So the first one I'm going to differentiate. Second one I'm going to integrate. So differentiate and integrate. Now derivative of x or du will be 1 dx. Differentiate the first one, integrate the second one. Now integration of cosine, I will have v. If we integrate, I will get sine x. So differentiate the first, integrate the second one. Now multiply x times v. So the integration now, x multiplied by cosine x dx will be to this one, u multiplied by v, which is x multiplied by sine x minus the integration of v du. V is sine x and du is 1 dx. So x cosine x equal to x multiplied by sine x minus integration of sine x dx. It is this form. And you can see integrating by part, it means that we are integrating partially, part of the function in the first step and the second part in the second step. That's why we call it integration by part. We integrate part of it and differentiate the first function and integrate the second one. Now, integration of sine x is easy to find. So the integration will be x multiplied by sine x minus integration of sine is minus cosine plus constant c, or I just can write it as x multiplied by sine x plus cosine x plus constant c. So this is the integration of x cosine x dx. Now the question that we started with. Which part should I choose to be u substitution and which part is dv? And this is the question now, will be how to choose u. So we say let u be the function coming first in the list. I have list which is start with L, I, A, T, and E. L8 is written as L, I, A, T, and E. What's the meaning of this list? D8. L for the function, logarithmic function. If I have logarithmic function in the integration, I will choose it to be u substitution for the integration by parts. I for the inverse trigonometric function. A for algebraic. Functions. T or T for trigonometric. And E for exponential. So this is the list, D8. So the function coming first in the list, I will choose it to be u substitution, and the other one will be dv. So L for logarithmic function, inverse, algebraic, trigonometric, and exponential function. And that's why, if you just go back to our example, I choose u to be x because this function, it is algebraic and trigonometric, a and t. And a is coming first in the list. Let's take another example. I want to evaluate. And this will be my second example now. What is the integration of x e to power x dx? X e to power ex. You can see that I have two types of functions. The first one is algebraic. Second one is exponential. So I have e or a and e. Two types, algebraic and exponential. And you can see algebraic is coming first and e is coming in the last. So I will choose u to be x. Let u equal to be x. dv will be e to power x dx. Now, as we did before, differentiate the first one and integrate the second one. Differentiate and integrate. So du will be 1 dx. Now, if we integrate, I will get v equal to e to power x. Now, multiply du multiplied by v. So the integration x e to power x dx is equal to, it is u multiplied by v minus v du. So I will have u, which is x times e to power x minus second one, that will be integration of v is e to power x du, which is 1 dx. So the integration now will be, or the final answer will be x multiplied by e to power x minus integration of e to power x is e to power x plus constant c, because this is indefinite integral. So this is the idea of the integration by part. Just divide the integration function into two functions, u dv, differentiate the first one, integrate the second one, and apply the rule of the integration by part, uv minus integration of v du. And the problem will be easier to find the integration.